In this video, we're going to learn how to use the SSS and SAS Similarity Theorems to prove that triangles are similar. So here's SSS. It says that if the corresponding side length of two triangles are proportional, really important keyword, proportional side length, then the triangles are similar. And here's an example, triangle ABC and RST. And notice that AB, which is here, and RS is, that's a proportion, that's a ratio. And then the second ratio, they take it as BC and ST. And then the third one is the, AC right here, AC and RS, okay? So all of the sides, they have to be, all of their ratios have to equal each other in order to prove that the two triangle ABC and RST are congruent. So let's see how we use this. Before we start, I want to point this out. This is so helpful. Look here. When using SSS Similarity Theorem, compare the shortest sides, the longest sides, and then the remaining sides. So I left the majority of the notes here to help us with it. So it's saying is either DEF, which is right in the middle, or GHJ, which is on the right, are they similar to the first triangle? So let's see how we compare those two. We're going to compare the shortest sides first. I'm going to erase this just so that we can look at it more clearly. The shortest side is AB, right, because it's at 8. AB over DE, so that would be 8 over 4, and that gives me 2. Then the longest side is AC or CA, and over FD, so that would be 12 over 8, and I have 3 halves. These two are not the same. Okay, and then the remaining sides, I only have one remaining side, so it's BC over EF, and that will be 9 over 6, and that's 3 half as well. So because not all the ratios, meaning this one right here really sticks out, right? This one do not equal the other two, so they are not equal. They're not equal. Therefore, these two triangles are not similar. Okay, that's what it says. Remember, if you recall the previous unit, the angle-angle postulate, similarity postulate, states that if two angles, really if 3 angles are congruent, the triangles are similar. In this case, the 3 sides have to be proportional in order for the two triangles to be similar. So let's look at the next one, ABC and GHJ. And the shortest side is AB again, over GH is the shortest on the other side. So I should have 8 over 16, that's 1 half. CA's corresponding side is JG, so that's 12 over 24, that's also 1 half, it looks good. The last remaining side is BC over HJ, and that's 9 over 18, and that is also 1 half. And because all the ratios are equal, so these two triangles, ABC and the large one, GHJ, are similar to each other. Okay, so that's how we use it. Here's another example. I left the majority of the notes on as well because it deals with a proportional. My apologies. That's my daughter who keeps texting me. So, and I need to be the taxi mom to go pick her up. But let's look at this first. Find the value of x that makes triangle ABC similar to triangle DEF. So how do we do this? It's very much the same thing. So we need to make sure that we know who are corresponding to each other in terms of corresponding sides, right? So here, BC is looks to me BC is the shortest side. So BC is 4, and the shortest side on the bigger triangle is EF, and that length is 10. So 4 over 10 has to equal to x minus 3, which is the AB, and DE would be 20. Now, if you just do your algebra, you cross multiply, use the cross product property. So 10 times x minus 3 has to equal 4 times 20. And that should give you 80 on the left-hand side. If you use distributive property, you can simplify it to 10x minus 30 on the right-hand side. You do a little bit of arithmetic. X is 11. So that's how you find the value of x. Now, does this make sense? So we have to check if our answer makes sense or not when x equals 11. So we substitute x with 11 to calculate the length of AB, and that should give me 8. And I do the same with DF, and that should give me 25. And now if I do my, now I know all the side length, I can just take my proportion. Hopefully they check out. This one, yes. This one does check out. This is a yes, right? And BC is, what's BC? That's 4 over 10. And is that the same as 10 over 25? If I simplify both, yes, this two check out as well. So my conclusion is when x is 11, the triangles are similar to each other by side similarity theorem. That's how we use that. So this one is a little bit more complex because of the algebra involved, but the concept is exactly the same. Simple concept. All the sides have to be proportional. Here is the second theorem for this unit. It's the SAS Similarity Theorem. And this one says if an angle of one triangle is congruent to an angle of a second triangle. So that's our first condition. In our example here, angle X and angle AM have to be congruent to each other. And, meaning in addition to that, the length of the sides includes these angles. The length of the sides includes, including these angles, are proportional. Meaning the corresponding sides MP over XC, change the color. The other side, oops, sorry. It's really hard to draw on the iPad. MN, right here, this one, over XY. So they have to be proportional. Their ratios have to be exactly the same. And then these two triangles are similar, okay? And here's your simplified version right here. So if the two angles are congruent here, and then these two ratios are exactly the same, meaning they're proportional, then the two triangles are similar. Let's see how we use this. Here's a messy drawing that represents the real world. The real world application is always a little bit messy. However, if you figure out what are the key information you need, you only look at those and use the appropriate tools that you have. They're actually just as easy as the normal questions that we deal with. So you're drawing a design for a bird feeder. Can you construct the top? Notice the top, ABC, is a triangle, so that it's similar to the bottom, which is also a triangle. So you want the top and the bottom, the two triangles, to be similar. Let's see. What do we have here? If I use screen here, I have, I'm comparing the ABC. I should use highlighters. So just give me a line. I'm comparing ABC, this triangle here, with DEF. Okay, so if I do that, I like what I see with all these numbers. Do you notice that, first of all, I've got congruent, one angle that's congruent. And secondly, look at that, there's something about the side length. So let's see what we can do about this. This probably is pretty easy looking from the numbers. It's not as messy as the drawing. So we already pointed out the angle B and angle E are congruent because they're both at 87 degrees, right? So then next we have to compare the ratios of the side length. That's but the side length I cannot consider AC because AC is not touching angle B. So I have to consider AB and CB, AB and BC rather. So let's see, corresponding side for AB would be DE. So AB over DE, according to our SAS Similarity Theorem, has to equal to BC over EF. And that's 32, for both of them is 32 over 20, which comes out to be 8 over 5. And so in other words, they are proportional. So by the SAS Similarity Theorem, the two triangles are similar. So you can make the top similar to the bottom. Okay, so let's reflect upon it. The reason when I first saw this graph, I thought it was really messy because it's a birdhouse, it's real life application. Then it's asking me to evaluate if I can construct the top so that it's similar to the bottom, given all the information. And the first thing that was most useful to me was this angle, the angle that the two angles that are equal to each other. The second one I noticed was, look at the side length. Without calculating it, I got a sense that they are proportional. So that's the approach that I chose, SAS Similarity Theorem. That way I can prove the two triangles are similar. So I know that I can construct the top to be similar to the bottom. So it's not, the math involved is not hard at all once you know how to identify the key information. Let's see what we have here. That's just a summary of what we've got so far. Make sure that you understand this. This is really, really helpful. Okay, this is our last example. Tell what method you would use to show that the triangles are similar. I got rid of the guided notes. I'll lead you through this because by now you should be fairly familiar with all three theorems, or rather two theorems and one postulate we just learned in the previous 2 units. Before we start, they provided a hint here. It says that to identify corresponding parts, redraw the triangles so that the corresponding parts have the same orientation. You can do this for those of you who are really artistic and have the spatial reasoning skills. For me personally, I flunked my art class at the age of 7, so for me to reorient a triangle, as silly as it sounds, I simply cannot do that. I have a mental block to do that. So what I then do is I use different ways to color code my angles, to use different symbols to indicate the different corresponding sides and angles. So let's look at this. These two triangles, PQR and TSR. So the shortest sides are 9 and 12. I'm color coding it. And another side I'm given is 18 and 12. It looks like that may be the longest side. So, and also notice that I've got, get rid of the blue. There we go, almost, there we go. Also notice that I've got this is a blessing. This is a vertical angle right here, right? So because of that, AA is out because I don't have information about two angles. I only have information about one angle. I don't have enough information to derive out of another pair of congruent angles. So AA is out. SSS is out because I don't have any information about the third side, nor can I derive the length of the third side. So it looks to me this is SAS if all things work out, because I've got the vertical angle that's congruent. I've got information about the sides that's hugging that angle. So let's go ahead and do the shortest side, which is QR. If I can prove that they are proportional, then I've got similarities there. So QR over RS, and that should be 9 over 12. It's my green. And that's 1/3. So that's one side. And then I've got PR over RT. And that's 18 over 24. Haha. That's excellent. They are proportional. The corresponding sides are proportional. So that's one criteria hit. And I also know that my angle PRQ is congruent to my angle SRT because they're vertical angles by vertical angle theorem. And therefore now I can draw the conclusion that the two triangles PQR is similar to triangle TSR, and that's by SAS Similarity Theorem. Okay? So not difficult at all, but you do need to go step by step. If you mess up the steps, that's when it leads you to the wrong path. Okay, guys? Thank you. See you in the next unit.